When a generator is not a separately derived system, and you are running a generator enclosure conductor with the other conductors, the termination point for the generator enclosure conductor is a critical safety and code compliance matter. The generator enclosure conductor must be terminated at a suitable disconnect switch that is located outside the generator enclosure. This is a vital safety measure to ensure that personnel can safely isolate the generator from the electrical system in the event of a fault or during maintenance procedures. The disconnect switch serves as the primary means of disconnecting the generator from the load, providing a safe working environment for electricians and other qualified personnel. The selection of the disconnect switch is paramount and requires careful consideration of the generator's electrical characteristics and the potential fault currents that the generator can produce. The disconnect switch must be rated for the maximum fault current that the generator is capable of supplying. This rating is typically expressed in amps and indicates the switch's ability to safely interrupt a short circuit or ground fault condition. Selecting a disconnect switch with an inadequate fault current rating can lead to catastrophic failure of the switch, posing a significant safety hazard. The location of the disconnect switch is also critical. It must be readily accessible without requiring entry into the generator enclosure. This accessibility ensures that personnel can quickly and easily disconnect the generator in emergency situations. Furthermore, it minimizes the risk of exposure to hazardous conditions within the generator enclosure, such as high voltages, rotating machinery, or exhaust fumes. The installation and connection of the generator enclosure conductor to the disconnect switch must strictly adhere to all applicable codes and standards, including the National Electrical Code, or NEC, and any relevant local regulations. These codes and standards provide detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. Failure to comply with these requirements can result in unsafe conditions, equipment damage, and code violations. The generator enclosure conductor serves a crucial role in providing a low impedance path for fault currents to return to the source, which helps to facilitate the rapid operation of overcurrent protective devices, such as circuit breakers or fuses. This rapid operation helps to minimize the duration of fault currents, reducing the risk of electrical shock, fire, and equipment damage. The size of the generator enclosure conductor must be appropriately sized based on the generator's output capacity and the requirements of the electrical code. Generally, the size of the generator enclosure conductor is determined by the size of the generators and grounded conductors. The NEC provides specific tables and guidelines for determining the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. It is important to consult these tables and guidelines to ensure that the generator enclosure conductor is adequately sized. The connection of the generator enclosure conductor to the disconnect switch must be made using approved methods and materials. The conductor must be securely terminated to the disconnect switch using appropriate connectors or lugs. The connection must be tight and free from corrosion to ensure a reliable electrical connection. In addition to the generator enclosure conductor, the generator enclosure itself must also be properly grounded. This grounding is typically achieved by connecting the generator enclosure to a grounding electrode system such as a ground rod or metallic water pipe. The grounding of the generator enclosure helps to minimize the risk of electrical shock by providing a low impedance path for fault currents to return to the source. The size of the grounding electrode conductor must be appropriately sized based on the requirements of the electrical code. A connection of the grounding electrode conductor to the generator enclosure and the grounding electrode system must be made using approved methods and materials. Regular inspection and maintenance of the generator enclosure conductor, the disconnect switch, and the grounding system are essential to ensure continued safe and reliable operation. These inspections should include visual examination of the conductors, connections, and equipment for signs of damage, corrosion, or loose connections. Any deficiencies identified during these inspections should be promptly corrected to prevent potential hazards. In summary, when a generator is not a separately derived system, the generator enclosure conductor must be terminated at a suitable disconnect switch located outside the generator enclosure. The disconnect switch must be rated for the maximum fault current that can be supplied by the generator and must be accessible without entering the generator enclosure. The installation and connection of the generator enclosure conductor must strictly adhere to all applicable codes and standards to ensure safe and reliable electrical installation. The disconnect switch should be selected with consideration for the interrupting rating. This is the maximum current the switch can safely interrupt without being damaged. Verify that the interrupting rating is sufficient for the generator's potential fault current. A higher interrupting rating than required does not hurt, but a lower rating could lead to switch failure during a fault. The location of the disconnect should comply with all applicable codes, like the NEC. The NEC often specifies working clearances around electrical equipment to ensure safe access for maintenance and operation. Make sure the location allows for these clearances. Consider environmental factors when selecting the disconnect switch. If the location is exposed to the elements, choose a switch rated for outdoor use with appropriate ingress protection, or IP rating. The IP rating indicates the degree of protection against solid objects and liquids. Proper labeling is essential for safety. Clearly label the disconnect switch with its function, such as generator disconnect switch. This helps prevent confusion and ensures that the correct switch is used in an emergency. Regularly inspect the disconnect switch for signs of wear and tear, corrosion, or damage. Replace the switch if any issues are found. Scheduled maintenance helps ensure the switch remains in good working order. Consider the type of disconnect switch needed. There are various types, including fused and non-fused disconnects. Fused disconnects provide overcurrent protection in addition to disconnecting the circuit. Choose the type that best suits the application's needs. Ensure that all connections are properly torqued according to the manufacturer's specifications. Loose connections can cause overheating and potentially lead to a fire. Use a calibrated torque wrench to ensure accurate tightening. When working on electrical equipment, always follow lockout-tagout procedures to prevent accidental energization. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to indicate that work is in progress. If you are not familiar with electrical work, consult with a qualified electrician to ensure the installation is done safely and correctly. Electrical work can be dangerous if not performed properly. Before starting any work, review the generator's documentation and any applicable codes and standards. This helps ensure that you are following the correct procedures and meeting all requirements. The grounding system of the generator is critical for safety. Ensure that the generator enclosure is properly grounded to a grounding electrode system. This helps to prevent electrical shock hazards. The size of the grounding electrode conductor should be determined based on the size of the generator's ungrounded conductors. Consult the NEC for specific requirement. The connection of the grounding electrode conductor to the generator enclosure and the grounding electrode system must be made using approved methods and materials. The connection must be tight and free from corrosion. Regular inspection and maintenance of the grounding system are essential to ensure continued safe and reliable operation. Check for signs of damage, corrosion, or loose connections. Any deficiencies should be promptly corrected. Consider the use of a surge protective device, or SPD, to protect the generator from voltage surges. Surges can damage sensitive electronic equipment. An SPD can help to mitigate this risk. The SPD should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Ensure that the SPD is properly grounded. Regular inspection and testing of the SPD are recommended to ensure that it is functioning properly. If the generator is connected to an automatic transfer switch, or ATS, ensure that the ATS is properly installed and configured. The ATS automatically transfers power from the utility to the generator during a power outage. The ATS should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Regular testing of the ATS is recommended to ensure that it is functioning properly. Consider the use of a remote monitoring system to monitor the generator's performance. A remote monitoring system can provide alerts if there are any issues with the generator, such as low fuel level, high temperature, or low oil pressure. This allows you to take corrective action before the generator fails. The remote monitoring system should be installed in accordance with the manufacturer's instructions. If the generator is used in a critical application, such as a hospital or data center, it is important to have a backup generator. This ensures that power is available even if the primary generator fails. The backup generator should be properly maintained and tested regularly. Consider the use of a load bank to test the generator's capacity. A load bank simulates a real-world load and allows you to verify that the generator can handle the expected load. Load bank testing should be performed periodically to ensure that the generator is operating within its design parameters. If the generator is used infrequently, it is important to exercise it regularly. This helps to prevent fuel degradation and ensures that the generator is ready to operate when needed. Exercise the generator for at least 30 minutes per month. Consult the generator's documentation for specific recommendations on exercising the generator. If the generator is located in an area that is prone to flooding, consider installing it on a raised platform. This helps to protect the generator from water damage. Ensure that the platform is strong enough to support the weight of the generator. If the generator is located in an area that is subject to extreme temperatures, consider providing additional ventilation or insulation. This helps to maintain the generator's operating temperature within the recommended range. Consult the generator's documentation for specific recommendations on ventilation and insulation. If the generator is located in an area that is subject to high winds, consider securing it to a concrete pad or other foundation. This helps to prevent the generator from being blown over. Ensure that the foundation is strong enough to withstand the expected wind loads. If the generator is located in an area that is subject to seismic activity, consider installing seismic restraints. This helps to prevent the generator from being damaged during an earthquake. The seismic restraint should be designed and installed by a qualified engineer. If the generator is located in a hazardous location, such as an area where flammable gases or vapors are present, it must be installed in accordance with the requirements of the NEC. The NEC specifies requirements for equipment installed in hazardous locations. Consult the NEC for specific requirements. Ensure that all personnel who operate or maintain the generator are properly trained. Training should include instruction on the safe operation of the generator as well as troubleshooting and maintenance procedures. Keep a record of all maintenance and repairs performed on the generator. This record should include the date of the maintenance, a description of the work performed, and the name of the person who performed the work. This record can be used to track the generator's performance and identify any potential problems. Consult with a qualified electrical engineer to determine the specific requirements for your generator installation. An electrical engineer can help you select the appropriate equipment and ensure that the installation complies with all applicable codes and standards. If you are unsure about any aspect of the generator installation, consult with a qualified electrician. An electrician can provide expert advice and ensure that the installation is done safely and correctly. Remember that electrical work can be dangerous if not performed properly. Always follow safety precautions and consult with qualified professionals when necessary. Furthermore, when selecting the location for the external disconnect, prioritize a location that is easily accessible during both day and night. Adequate lighting should be provided around the disconnect switch to ensure visibility during nighttime emergencies. Consider the potential for future expansion or changes in the electrical system. Choose a location for the disconnect switch that allows for future modifications without requiring significant relocation or rewiring. Ensure that the disconnect switch is protected from physical damage. Avoid locations where it could be struck by vehicles or other equipment. If necessary, install barriers or other protective measures to prevent damage. Consider the potential for vandalism. Choose a location that is not easily accessible to unauthorized personnel. If necessary, install a lockable enclosure to protect the disconnect switch. When installing the disconnect switch, ensure that it is properly aligned and mounted securely. Use appropriate hardware and mounting techniques to prevent the switch from becoming loose or misaligned over time. Ensure that the conductors are properly supported and secured to prevent strain on the disconnect switch terminals. Use cable clamps or other support devices to keep the conductors in place. When making connections to the disconnect switch terminals, use the correct size and type of connectors. Ensure that the connectors are properly crimped or tightened to provide a secure electrical connection. After completing the installation, test the disconnect switch to verify that it is operating correctly. Use a multimeter to check for continuity and voltage at the switch terminals. Document the installation details, including the location of the disconnect switch, the type of switch used, the conductor sizes, and the grounding details. This documentation will be helpful for future maintenance and troubleshooting. Review the installation with a qualified electrician or electrical inspector to ensure that it meets all applicable codes and standards. Obtain any necessary permits or approvals before energizing the generator. Finally, proper planning and execution are essential for a safe and compliant generator installation. By following these guidelines and consulting with qualified professionals, you can ensure that the generator enclosure conductor is properly terminated and that the electrical system operates safely and reliably. Remember to always prioritize safety and to consult with qualified professionals when in doubt.